This time we get to be the ones to graph these systems of inequalities, and then we'll determine some solutions. So, step 1, solve for y. Make sure it's in slope-intercept form. Step 2 is to graph our boundary line. Remember, if it's less than or equal to or greater than or equal to, we have a solid line. If it's strictly less than or strictly greater than, it is a dashed line. And then we'll shade. If it's greater than or equal to, we're shading above. If it's less than or equal to, we're shading below. Now the difference here from what we had before is since we have two inequalities, there are going to be two places that we could shade. We only want to shade where that overlaps. But we'll get to that in a second. Okay. Y is less than or equal to 3, and y is greater than or equal to negative x plus 5. Thankfully, this one is already in slope-intercept form, so there's nothing to move around. So now we can go ahead and start graphing. For y less than or equal to 3, that's going to be a horizontal line at 3. Since it's less than or equal to, it's going to be solid. So through 3, we've got a solid line. Then, y is greater than negative x plus 5. I'm going to start by plotting the y-intercept. So we're going up 5. There's our y-intercept. And then we have a negative slope of 1. So we'd go down 1 and to the right 1 to find some other points. And this time it's greater than, strictly greater than, so we're going to do a dashed line through those points. Now is where we worry about the shading. I'm going to do some light shading for each one, and then I'm going to do a darker shading for the actual result that we want. We want to be less than or equal to 3, so for that would be everything that's underneath that line for 3. We also want to be greater than negative x plus 5, so that's everything above negative x plus 5. But the actual shading that we care about is where they overlap. So notice they only overlap in this little triangular section underneath the red line, but above the blue line. So what I'm going to do is get rid of the other shading and then actually shade in that overlap. So here's where those two regions overlap. Now when we're doing solutions, we can do any of the solutions that are on our solid line or in our shaded region in the area where they overlap. So we're not going to pick a point that's on our solid line underneath the blue line, but we could do anything on our solid line above the blue line or in this shaded region. So some examples that are solutions might be 5, 1, 4, 3, 5, 2, anything that's either in the shaded region or on our solid line that's touching the shaded region. Examples that are not solutions. 0, 3 is not a solution. It may be on the solid line, but it's not touching that shaded region. 0, 0 is not a solution. It's not even in the shaded region or touching a solid line at all. 3, 2, not a solution. It's on our dashed line, but it's not on a solid line, and it's not in our shaded region, so that one doesn't count.